Hi everyone. My name is Jack and I've been working as part of the VMS Thematic Research Project at LU, looking at the late stage geodynamic evolution of the Superior Province. But more recently I've been working on a newly discovered gold deposit up in the Red Lake Greenstone Belt called the Great Bear Deposit. Now this research has been supported by Kinross, who have pretty much provided unrestricted access to all of their drill core, their petrographic reports, GIS data sets, geochemistry, etc. So this research wouldn't be possible without them. But also a lot of collaborators within Laurentian itself, and also Stephanie Bruckner, who's the key PI for the overarching project, which I'll discuss a bit later, and also Mike Hamilton, who's been facilitating a lot of the TIMS dating for this project. So I've given an iteration of this talk previously, but this is going to be a lot more comprehensive and there's a lot to go through. So I'm going to go through some of the earlier slides pretty quickly, but basically I'll give an overview of the Red Lake Greenstone Belt, overview of the Great Bear property, some of the key scientific questions we hope to address within our study of the LP fault zone, then discuss the geology and stratigraphy of the LP fault zone, the geochemistry and geochronology, and ultimately the implications of those results for exploration, and then what's next for the overarching project. So Superior Craton records the early formation of continental and oceanic crusts, consists of 19 sub-provinces that host multiple world-class base metal and gold deposits, but most of the notable orogenic gold deposits occur within the Abitibi Greenstone Belt, associated with the Porcupine-Desta Fault Zone and the Cadillac-Lighter Lake Deformation Zone, but also up in the Red Lake Greenstone Belt in northwest Ontario, which is the major focus of this talk. So this is the Red Lake Greenstone Belt. It's one of 6 major greenstone belts that define the Uchi sub-province, and it records 300 million years of volcanism, intrusive magnetism, sedimentation and metamorphism, attributed variably to mantle plumes, arc volcanism and late-stage tectonic uplift. And it hosts some of the largest and richest orogenic gold deposits in Canada, and it's produced upwards of 30 million ounces of gold. So exploration has historically prioritised the so-called mine trend. I don't know whether you can't see it, but it's basically a small belt that extends from Kochna to Barmatown. It's a corridor of east to southeast trending D2 structures that formed during the 2720 Uchian orogeny, and it's typically associated or inferred to be associated with the amalgamation of the Winnipeg River terrain towards the south with the Uchi subprovince to the north. And most of the major mines are located within this mine trend. That includes the Kochna and Campbell Red Lake gold mine, which has produced upwards of 15 million ounces of gold, and it's currently operated by Evolution. Another key point is that gold mineralisation within this mine trend is typically hosted by thallitic and komatitic metabasalts of the Barmah assemblage, which dates from 2.99 to 2.96 billion years, and it's the oldest stratigraphic assemblage within the Greenstone Belt. And what's, I suppose, unique about Great Bear Resources discovery is that it's 25 kilometres southeast of the major gold camp. It's sort of in the middle of nowhere, up against the highway, so it does raise the possibility that there are other big gold deposits within the Greenstone Belt itself. Now, this is basically a geological map provided by Kinross, and it shows, I suppose, 2 major domains, the LP fault zone and the mafic domain. The mafic domain has been sort of the site of exploration since mid-1940s, and a lot of exploration has targeted this so-called limb zone and hinge zone, but it wasn't until Great Bear started doing a big systematic survey in 2019 of the LP fault zone that they discovered widespread disseminated gold. Now what's interesting is the LP fault zone has previously been mapped as part of this so-called McNeely sequence of the Confederation assemblage. It dates from 2748 to 2742 million years, but there are no real firm geochronological or geochemical constraints to support that conclusion. There's very limited outcrop out there, so the geology was probably interpreted from geophysics and facies analysis of some of the limited outcrop. So part of our project is to ultimately provide those geochronological constraints to determine if it is part of the Confederation assemblage, which has historically thought to be largely barren in mineralisation. So there's three key styles of mineralisation across the property. We have quartz veining in mafic volcanics in the hinge zone. We have silica sulfide replacement in the limb zone. And within the LP fault zone, we have disseminated gold, and that's typically occurs within the major foliations of the footwall of the LP fault. So recently, within the last sort of month, Kinross has released a resource model for the LP fault zone. They basically suggest there's 2.7 million ounces of gold indicated, 2.3 million ounces of gold inferred. You can see the blue here represents sort of 0.5 grams per tonne of gold, the red 3 grams per tonne, and the purple, which is probably a bit hard to see, is 5 grams per tonne. But most of their drilling has been limited to the top 500 metres, and there's probably very limited drilling below that depth, so there's still possible that there's higher grade targets at depth and also further along strike of the LP fault. So it's somewhat semantic and arbitrary, but world class is thrown around a lot, and what there is an actual definition of world class in terms of gold. So Singer defined it as anything more than 3.2 million ounces of gold, so 100 metric tonnes, based on Kinross's recent estimates. Yes, it probably is a world class gold deposit, and exploration is likely to continue, so that that resource will probably increase with time. So we have three key scientific objectives for our research in the LP fault zone. So as part of this study, we're not studying the limb zone and the hinge zone, just the LP fault zone, which hosts a lot of the gold mineralisation. So we hope to characterise the main facies relationships between the various metasedimentary and subvolcanic units on the property to constrain their paleo-environmental conditions at the time of deposition, but also to provide context for some of the uranium lead dating that we'll do. We also wanted to determine the crystallisation age of some of the zircons from the porphyries within the LP fault zone, and also the age of some of the detrital zircons from the metasedimentary succession. So this is a more detailed geological map. The GIS data was provided by Kinross, and it shows the LP fault zone. So the yellowy brown colours are porphyries, and the grey are basically metasediments. The point I want to get across here is that the stratigraphy is being flattened, attenuated. It's very highly strained. It's difficult to identify proper depositional textures. And it's very difficult to identify fold hinges, closures, or vergence directions, particularly in drill core. And the primary foliation tends to trend northwest-southeast, although it should be noted it does rotate along strike of the foliation. And I suppose broadly speaking, if you compare this with the major mine trend in the Red Lake Greenstone Belt, that also trends northwest-southeast. So I studied approximately 10 drill holes from the property, and Great Bear Resources and Kinross have previously defined 7 key lithofacies. There are obviously sub-facies within that, but there are 7 key major stratigraphic units that we've retained as part of this study. So we have this metasedimentary unit 1, it's likely the youngest unit on the property. We have this fragmental unit 1, a second metasedimentary unit, a distinct quartz feldspar porphyry, an altered porphyry, and then a third metasedimentary unit. And then we have this sort of obscure fragmental unit really immediately adjacent to the LP fault. So I'm just going to go through systematically the stratigraphy, and then we'll delve into the geochemistry and geochronology. So the metasedimentary unit 1, it's the furthest away from the fault, located towards the northeast. It's thinly bedded. It's the only unit that really preserves proper depositional features. It's fine to medium grained, and there's some rare graded bedding that would indicate a east Yanging direction. Often interbedded within that unit, we have this fragmental unit. It's poorly sorted, it's matrix supported, and it's likely a volcaniclastic deposit. It has these 4 to 5 millimetre sized quartz and feldspar crystals, and also these larger QFP fragments that were likely derived from this underlying QF porphyry, which has been locally termed E31. So you can see in this top picture here, we've got the interbedded MS1 and F1. It's a bit hard to see in part B, but we have this volcaniclastic unit that overlies this E31 porphyry, and at the interface of those two units, so between the E31 porphyry and the volcaniclastic unit, we have this possibly recrystallised haloclastite. It's a bit of arm waving, but that's what we've interpreted it as, and it probably represents quench fragmentation. Going down into the stratigraphy, so we have E31. It's grey to dark grey, medium to strongly foliated. Generally consists of white feldspars, and there's very distinct blue, grey-white quartz phenocrysts. And it's obviously in a very fine-grained ground mass. And then metasedimentary unit 2, it's intensely foliated, massively thinly bedded, and it has garnet, staurolite, and andesite porphyroblasts. And I think it's been graded at sort of upper green schist, lower amphibolite facies. So in the top unit here, top image here, we've got these distinct garnet bands and sericite alteration bands. In these sort of thin section images, we have biotite that's wrapping around the garnet. And in this bottom image, we have the contact between this second metasedimentary unit and the E31 porphyry. There's few real indicators that indicators that it was emplaced within wet, unconsolidated sediments, so we don't really see any evidence of pepperite, but we do see chilled margins, so it could be simply that the high level of deformation has destroyed a lot of the primary textures that would indicate these features, but we have other indicators to support our conclusions for the paleo environmental setting, which I'll discuss in a sec. So we also have this altered porphyry. Now, one of the key questions we came into was, is the altered porphyry simply an altered version of this E31 unit? And what we can see in core is that the units are quite distinct and sharp. So what we're suggesting is that this so-called E32A unit, so it's an altered porphyry, we don't really see these distinct blue quartz phenocrysts. There's minor plagioclase phenocrysts. There's a lot of secondary alteration. So we think that porphyry was in place first within this metasedimentary succession, then experienced alteration and was subsequently intruded by the distinct quartz feldspar porphyry of E31. And lastly, we have the metasedimentary unit 3 and this fragmental unit 2. Now, both these units are immediately adjacent to the LP fault. So I should mention the LP fault is a big crustal-scale fault. It was originally identified as part of the lithoprobe seismic survey and was discussed in a few papers in 2004, 2006. It's named LP for lithoprobe, but basically immediately adjacent to this fault, the units all exhibit extremely intense deformation and alteration. So a lot of the metasedimentary unit 3 units, it's pretty difficult to identify bedding at the best of times, but it's extremely strongly foliated with a lot of sericite alteration. And fragmental unit 2, which is immediately adjacent to the fault, it appears to be, at least from what I saw, gradational with MS3, has subangular to sort of round sericitically altered fragments. And it could be a conglomerate or a breccia, but it also could be just the simply boudinage component of MS3. So now we'll go into sort of the paleo environment. So we interpret the metasedimentary units to be largely part of the one succession that was likely deposited in a structural basin facilitated by subsidence along the LP fault, and that variations within the sedimentary facies are probably attributed to variations in deformation and metamorphism. It's likely that E32A was emplaced first. It underwent alteration and was subsequently intruded by E31, which is the major quartz feldspar porphyry. And it's also likely that E31 breached the C4, producing a lava dome that experienced quench fragmentation, autobrecciation, and then you had sort of debris flows from that formed the volcaniclastic deposit, and that was subsequently interbedded within MS1 and possibly MS2 as well. But now I want to delve a bit more into the geochemistry and the geochronology, because that has sort of more regional implications. So one of the reasons I've compiled all the geochemistry from the Red Lake Greenstone Belt, and one theory I wanted to test was, can you pick up a rock from the Greenstone Belt and assign it to a specific stratigraphic assemblage just by analysing its geochemistry? And the answer is variably yes and no. I'll show that in a minute, but for the point, just for demonstration, or just for showing you the chemistry of the rocks for a start. So the LP fault zone porphyries are generally calc-alkaline and acidic to right acidic in composition. The E32A porphyries obviously have high silica contents and rare earth element values due to post-emplacement alteration, and they're pretty characteristic of type 1 rhyolites of Hart. So here is basically, there's various ways you can obviously compare geochemistry data, various major elements, trace elements, principal component analysis, biplots. But for the purpose of, I suppose, display, I've just plotted them all as rare earth element plots. They've all been normalised to primitive mantle. So the Balmer assemblage on the bottom left typically has very flat rare earth element signatures, characteristic, we think of probably plume tectonics. The Confederation assemblage, which is the other dominant assemblage throughout the belt, that has distinctive europium anomalies, so indicative of plagioclase fractionation. And that's the original assemblage that was thought to be in the LP fault zone. But what we find is that the porphyries from the LP fault zone all have relatively steep light rare earth element signatures, and they're pretty consistent with the so-called Graves assemblage, which is considered to be one of the youngest stratigraphic assemblages in the Greenstone Belt, albeit we don't have too many samples from the Graves assemblage to compare. So the question is, does that actually reflect the original, the age of the rock? So to test that, we sent some samples over to Mike to do some TIMS dating, and he managed to get zircons from both samples. E32A we always knew was going to be difficult, and he managed to extract one zircon. It was a bit altered and dirty, but he managed to get an age of 2729 or 2730. That's roughly coincident with the Graves assemblage, although this zircon is probably xenocrystic and not really representative of the crystallization age. But he also extracted two slightly discordant and one concordant zircon from the main E31 QF porphyry, and from that he obtained ages of 2722. So for a start, the stratigraphy isn't part of the McNeely sequence of the Confederation assemblage, but it's more likely part of the Graves assemblage or the younger St. Joseph suite. So we also did some detrital zircon dating and of the metasedimentary units, and basically what we see is the majority of zircons sort of cluster around 2730 to 2720. So again, it's probably likely that a lot of these zircons were derived from the porphyries. There are a few younger zircons, particularly within MS2 and MS3, that are really adjacent to the LP fault. There's a lot of analytical uncertainty associated with these analyses, but it's also likely that they were influenced by deformation, hydrothermal alteration, and metamorphism. So I don't put too much credence in some of these younger ages. So then, based on those ages, I decided to plot up the distribution of known 2732 to 2712 assemblages within the Red Lake Greenstone Belt. And what we see is most of them are within the core of the Red Lake camp itself and to the northwest of the Red Lake gold camp. And there are actually very few occurrences to the southeast of the Red Lake camp. Now, this could simply reflect, be an accurate reflection of the regional geology, or probably more likely an artefact of limited samples. So if you can see the white dots on the map, they all represent known geochronology samples. There are very few to the southeast of the main camp, probably a reflection of the fact that there's very limited outcrop, but it does suggest we probably should go out there and sample some of these belts more closely. But what's probably interesting is that the St. Joseph Suite, which is pretty much within the core of the Greenstone Belt, also includes the Albino granodiorite, the 2720 Mackenzie Island stock, and the 2717 Dome stock, and these all have established gold deposits, albeit a lot smaller than the main Red Lake mine. So what's the significance of these crystallisation ages? Well, it basically suggests that the maximum age for mineralisation in the LP fault zone is 2722 million years. However, we have noted that there are at least 3 different styles of mineralisation within the LP fault zone. So we have disseminated gold, which makes up the bulk of the gold, and that occurs primary to the parallel to the primary northwest-southeast trending foliation. We also have gold in transposed quartz veins that are also parallel to that foliation. And those are probably either syn intrusion or syn tectonic. This will be tested in subsequent studies, hopefully. And we also have free gold in quartz veins oblique to the primary foliation. So in terms of sort of the regional chronology of events in the Red Lake Greenstone Belt, so Dubé did a big study, geochronology study, and basically suggested that the main stage of gold mineralisation at the Red Lake mine occurred between 2723 and 2712, most likely coinciding with the Archean orogeny and the amalgamation of the Winnipeg River terrain and the Uchi subprovince. And he also suggests that there was a late stage gold mineralisation and remobilisation event that occurred after 2702. Now this chronology perfectly fits or could be also applied to the Great Bear deposit, but again, this involves a bit of arm waving, and hopefully this will be tested in the near future. So I thought I'd just do a quick comparison between the LP fault zone and the Red Lake mining camp. So both deposits are located adjacent to major unconformities and crustal-scale faults. Both deposits are located adjacent to sedimentary belts, and both deposits are hosted within a zone of predominantly northwest, southeast trending structures. So the mine trend is southeast trending, and the primary foliation within the LP fault zone trends northwest, southeast. And it's plausible and possible that mineralisation at both deposits was associated with the Archean orogeny. However, there are some differences. The gold at the Red Lake camp is principally hosted by the Barmer assemblage, while gold in the LP fault zone is hosted by the younger possible Graves assemblage or the St. Joseph Suite. And there's also different styles of mineralisation. So in the LP fault zone, gold principally occurs as disseminated gold throughout the host rock, while at the Great Bear property, at the Red Lake camp, gold occurs within carbonate veins. So we've been sort of lucky. Stephanie, Bruno and Doug were successful in applying for an alliance grant. This is partially funded by NSERC and Kinross, and as a consequence there will be at least 3 projects working on this property. So Stephanie will be supervising a PhD mineralisation project, looking at all of the 3 zones on the property. Bruno will have a master's project looking at the structural geology, and Doug will have a metamorphic project looking at the timing of metamorphism. And I've put this slide in here to plug Adam Muller's talk. He just published a paper in geology looking at the MT across the English River, the Uchi subprovince and the North Caribou terrain, and the implications of that for mineralisation. So he's talking tomorrow afternoon if you want to hang around for that. And basically thank you to everyone, particularly everyone at the site in Red Lake for all their help, Emily, Dylan, Rick, and also Graham and Guancalas for all your help in replying to my various emails. Thank you.
Thanks, guys. We do have time for a question. You've got great big pictures with lots of zircons. You only dated 1 zircon. 3 zircons. So what gives? Are those from those rocks? Or
Those are from those rocks, yep. difference in methods. One takes a lot longer and is costs a lot more money, but is a lot more accurate.
You know, if you're worried about anticrystic zircons or xenocrystic zircons in your altered work, you gotta do more.
Yeah, you can, but it becomes a cost. It costs.
That's the man with the money.
Yeah, we can also analyse some of these with the laser as well to test that. That's going to be a lot cheaper. My guess is the way
The uncertainty is a lot higher.
with the laser, yes, yeah.
A lot higher. So
Yeah.
you're gonna need to buy 16 times more zircon.
Oh yeah, this is just a representative batch from various samples. Yeah. Yeah.
And the laser that works.
Any plans on some geotechnology? In one of the talks, people talk about dating sometimes or some of the veins. Any plans to
Not me personally. So we've got a few projects in offer. Yeah, yeah.